questions, we could all see that for question 1, what we have there is 2 root 3 plus 5 root 27 minus 2 root 75. So question 1 is 2 root 3 plus 5 root 27 minus 2 root 75. So how do I go by solving this question? I can actually use the rules of surds to solve this. The first thing I'll notice is that I can make everything to be in root 3 because this 27 here is the same thing as 9 times 3, and also this 75 is the same thing as 75 divided by 3, that's 25. That's, you can say 75 is 25 times 3. So I can write it as 2 root 3 plus 5 root 9 times 3, which is 27, minus 2 root 25 times 3, which is what? 75. So from here we can say 2 root 3 plus the square root of 9 is 3. This 3 is coming outside. That means 5 times 3, that's 15 root 3. And the last part minus 2. This square root of 25 is 5. And this 5 is coming out. That's 5 times 2. So we have 10. 10 root 3. Okay, from here we can see that everything has root 3, which means they have common roots. Definitely I can bring their coefficients out and add them. So if I want to bring the coefficient out, I'm going to have 2 plus 15, which is 17. 17 minus 10, that's 7. So my final answer is 7 root 3. Final answer for question 1. Very short and simple. Now for question 2. How do we go for question 2 here? If you want to move forward for this question 2, you can see that the question is it's actually a product. So we have open a bracket of square root of 5 plus square root of 2 multiplied by square root of 5 minus square root of 2. Oh, this thing actually look like difference of 2 square, which means from here immediately we can all say that since it's difference of 2 square, you can say square root of 5 raised to power 2 minus square root of 2 all raised to power 2. Difference of 2 square. I've explained this in one of my videos when we were doing quadratic equation. You can check out for that. You can just search quadratic equation at Shams, you see it. So square root of this can take away this immediately, this can take away this immediately. So my final answer is 5 minus 2, which is then equals to 3. Alternative method. Maybe you don't really understand what I really do here. You can do it another way, that square root of 5 plus square root of 2 multiplied by square root of 5 minus square root of 2. So let's multiply this one after the other. What are we going to have? Square root of 5 times square root of 5, this times this times this. Also you now do this times this and this times this also. So doing those two things, we are going to have square root of 5 times square root of 5. Remember, square root of a times square root of a equals to a. Definitely square root of 5 times square root of 5 will be what? Ordinary 5. Square root of 5 times square root of minus 2, that's minus square root of 5 times 2, 10. Square root of 2 times square root of 5, that's plus square root of 2 times 5, 10. Then plus times minus square root of 2 times square root of 2, ordinary 2. You can see that in this case, this thing will go away, this thing like this, because minus square root of 10 plus square root of 10 will give us 0. That means that one has left the expression there. So I'm left with what? 5 minus 2, which is then equals to 3. Final answer. So is it that you use this first method that I use here to get my answer here, or you use this method here. Now moving to the next question, question 3. Now for question 3, our question 3 is actually an equation. We have x plus square root of x equals to 6. Now they said find the value of x. This is actually very simple. Before you can find the value of x, first collect like terms. So if I collect like terms, I'm going to say x minus 6 equals to okay, don't let me collect like this way. Let me take this x out. That means square root of x is then equals to 6 minus x. Yes, this x will come here, and we are going to leave this one here. That's square root of x equals to 6 minus x. So let's square both sides. If I square both sides, I'm going to say that's square root of x square equals to open bracket 6 minus x all square. So from here, this can take the square root away, and I'm left with ordinary x is then equals to square of 6, that's 36. Now let's open this bracket by multiplying everything together to get the second term. That's 2 times 6, that's 12. 12 times minus x minus 12x. Then the last one, minus square, that's plus x square, x square. I've explained how to expand this when I was in one of my video, check quadratic equation. I show you the shortcut for it, and in that video also I explained binomial expansion. So moving forward from here, you can say let's collect like terms. Let's bring family to family. So we are going to say, let's leave this one here, let's bring this x over here, then we put it in a mirror. That means this x will now be seen here. So x square minus 12x plus 36, bringing this one here minus 6, minus x equals 0. Oh, this quadratic equation. Wow, that's nice. I've solved it. I've explained this before. So that would be x square minus 12x minus 1x, that's minus 13x plus 36 equals 0. Since we are doing surd and if I say I should factorize, is this even factorizable? Do you know I'm saying it? No, because this 13 here is a 13. Okay, the factor will be, that's 36. Then if I take the factors of 36, factors of 36 should be 9 times 4, and 9 times 4 will even give me 36. Yes. And then if I check here, I have minus 13. 9 plus 4 is 13. So from here, it is very visible that since I said 9 times 4 will give me 36, but 9 plus 4 is 13, not minus 13. Okay, let's put minus in both values. That's minus 9 minus 4. Minus 9 times minus 4 will give me minus 36. Minus 9 times minus 4 will give me pure 36. And then minus 9 minus 4 will give me minus 13. Definitely my factors are minus 9 or minus 4, which means from here I can say my x is then equals to 9 or 4. Final answer for x in that place. If you want to know how I solve this, I explained it in one of my video in quadratic equation. Search it, you see it, you can watch it there. Okay, from here moving to question 4. We see that question 4 is square root of x plus 3 minus x plus 1 then equals to 0. So how do I solve this kind of question? Why can't I just do it like question 3? You can actually pause the video and try it on your own. But let me just give you hints. The first hint you are going to take out is that collect items. So you can say that the square root of x plus 3 is then equals to x minus 1. So from here, what can I do? I can say square both sides. So if I square both sides, I can say x plus 3 all square is then equals to x minus 1 square. This can take away this, so x plus 3 is then equals to the square of this will be x square, that's x square, multiply everything, 2 times x times minus 1, that's minus 2x, minus 1 square is plus 1. So collecting like terms, I can say x square minus 2x plus 1 minus x minus 3 equals 0. So from here, I can actually join some things together. I can say x square minus 2x minus 1x, that's minus 3x. Then minus 1, plus 1 minus 3, that's minus 2 equals 0. So from here, I can bring these two together, that's minus 2x square. So can I factorize this? I don't think this should be factorizable, because if I want to take it, I can say the factors of minus 2 will be 2 times minus 1 or minus 2 times 1. And none of this will give me minus 3. Hence, it's not factorizable. So using quadratic formula that we say, compare it to ax square plus bx plus c equals 0. We can all see that our a equals to 1, b equals minus 3, and c equals minus 2. So from here, how do I take a step forward? Remember the quadratic formula that states that x is then equals to minus b plus or minus square root of b square minus 4ac all divided by 2a. So moving a step forward from here, I can say that let's solve our value into it. X is then equals to minus b, that's b is minus 3. Minus 3 times minus, that's ordinary 3, plus or minus square root of b square, that's minus 3 square. Minus square is plus, 3 square is 9, that's 9, minus 4 times a, which is 1, that's 4 times a, 4 times 1, 4. 4 times minus 2 minus 8, minus times minus plus 8, everything divided by 2 into bracket a is 1. So from here I can say x is then equals to 3 plus or minus square root of 8 plus 9 should be 17 divided by 2. So x is then equals to 3 plus square root of 17 divided by 2, or x should be 3 minus square root of 17 divided by 2. And that's the final answer for question 4. Now moving to question 5 now, which seems to be, okay, it's not even the last one, which seems to be like the penultimate. We can say question 5, we have square root of 2x minus 1 is then equals to x minus 3. This one here is very relating to question 4 and question 3. You can pause the video and solve it. So how do I go for this? I can say square both side the normal way we always go around. You can say 2x minus 1 all square is then equals to x minus 3 all square. This can take away the square root. So what am I left with? I'm left with 2x minus 1 is then equals to x square minus 3, 2 times this, 2x times this, that's minus 6x, minus 3 square is plus 9. So collecting like terms, I can say x square minus 6x plus 9, bringing this one here, minus 2x, bringing this one here, plus 1 equals 0. So finishing this, I can say x square minus 6x minus 2x, that's minus 8x, then 9 plus 1, that's plus 10, equals 0. So from here, please watch to the end. That question, the last question there, is very tricky that we need to apply so many rules to it. Okay, to finish this up, we can say, let's use quadratic formula very fast. Or can we factorize? No, the factors of 10 is always 5 and 2, and then no addition or subtraction of 5 and 2 that will give me 8. So I can say from here, a equals to coefficient of x square, which is what? 1. Coefficient of x is b, so b is minus 8 and c is 10. So recalling the equation, the quadratic formula that says x is equals to minus b plus or minus square root of b square minus 4ac divided by 2a. So you can say x is then equals to minus b, that's minus 8, minus 8 is plus 8, plus or minus square root of minus 8 square is minus times minus is plus, 8 times this is 64, minus 4 times 1, 4 times 10, 40, divided by 2 into bracket 1. So x is then equals to 8 plus or minus square root of the square root of 64 minus 10 minus 40, that should be 24. Yeah, 64 minus 40 should give me something close to 24. 24 divided by 2. So since we are in surd, this 24 can be simplified. You can say 8 plus square root of 24 over 2, or x equals to 8 minus square root of 24 over 2. Finishing this thing, you can say then x is then equals to 8 plus, this 24 can be written as 8 times 3, that's square root of 8 times 3 divided by 2, or x should be 8 minus 8 times 3 over 2. So finishing this guy, I can say x is then equals to 8 plus, this 8 here is the same thing as 4 times 3, and the square root of 4 times 2 rather, the square root of 4 is 2. Now I can say 2 root 3 times, I left something inside, I left 2 inside, so 2 times 3, that's 6, or divided by 2, or x is then equals to 8 minus what I did there, minus square root of 8 here can be written as 4 times 2 times 3, right? So from here we can say that we have what? X should be equals to 2 is common, 2 into brackets 4 plus root 6 divided by 2, or x should be equals to divided by 2, sorry, x should be equals to 2 is also common to everything. Oh, 2 is not yet common. 8 minus what's square root of 4? 2. Root 2 times 3, 6 divided by 2. 2 can take away 2 here, so x equals to 4 plus root 6, or x equals to, 2 is common, 4 minus root 6 divided by 2. 2 can take away 2, so therefore x equals to 4 plus root 6, or x equals to 4 minus root 6. And that's the final answer for question 5. Now moving to the last one and not the least, question 6. For this question 6, we notice that the question there is square root of 2 plus square root of 3 all raised to power x equals to square root of 2 minus square root of 3 all raised to power x. So how do I solve this kind of thing? How do I find the value of x? Oh, sorry, all raised to power minus x. So for me to finish this up, it actually look fun. But how do I find x in this kind of question? Since both are power, I don't might be thinking that can't x just cancel x away? No. Now how do we solve this? We can say this square root of 2 plus square root of 3 all raised to power x equals to this raised to power minus x is the same thing as 1 over square root of 2 minus square root of 3 all raised to power x. Yes, isn't it? So moving on, we can say multiply both sides by square root of 2 minus square root of 3 all raised to power x. Since I'm multiplying this with the left hand side and right hand side, the equation is still balanced. So I can say square root of 2 plus square root of 3 raised to power x multiplied by square root of 2 minus square root of 3 all raised to power minus all raised to power x, another x again, equals to, the only difference here is that we have plus here and we have minus here, equals to 1 over square root of 2 minus square root of 3 all raised to power x multiplied by square root of 2 minus square root of 3. From here, this can take away this immediately, all raised to power x. So what I'm left with is just this part, and if I'm left with this left hand side, I can say square root of 2 plus square root of 3 all raised to power x multiplied by square root of 2 minus square root of 3 all raised to power x equals to 1. So from here, to finish it up, we can notice that this one here look like difference of two squares. Yes, remember that a square minus b square is the same thing as a minus b multiplied by a plus b. Now taking what we have in the bracket here, let's take that a is square root of 2 and b is square root of 3. We can actually see that what we have here is then what? Difference of two squares. So I can say everything here can be written as square root of 2 square minus square root of 3 square, everything all raised to power x is then equals to 1. This can take away this immediately, this can take away this immediately. That means from this point, what I have is then 2 minus 3 all raised to power x is then equals to 1. So 2 minus 3 is minus 1, that is minus 1 raised to power x equals to 1. Wow, that means x have a number that can be either 0, 1, 2, 3, 4, 5, 6, but x is not all positive integer, neither all negative integer. Why do we say that? The only reason I say that is that since I have minus 1 raised to power x and it's giving me 1, that means x here can be what? All even number, not all odd number. Because if I do minus 1 raised to power any even number, it will give me plus 1. But if I do minus 1 raised to power any odd number, I'm going to get minus 1, which means x can never be odd number, it will be even number. That means from here I can then say something. What's that thing that I can say? I can say that x here is then equals to 2k. And what is k? K is any positive integer, 0, 1, 2, 3, 4, 5, 6, 7 to infinity. Remember, when you multiply any integer by 2, you get even number, which means x here is an even number. That means x can be 0, 2, 4, 6, 8, till any number of 2n. Yeah, this is how it is going. That means the best answer I can just give x in this place is that what is x is 0, that x should be 0, because any value raised to power 0 will give me what, will give me 1. So I can say x is then equals to 0, or you say that what minus 1 all raised to power 0, that one will give us what, 1. You can test it for this, and that's the final answer for x in question 5. Now please don't forget to like, share and comment. Don't just enjoy the video only. Thank you very much for watching. I really appreciate it.